Alright everyone, so here in this problem we want to find the tension in the cables when the elevator is not moving and when it's accelerating downward at 1.8 meters per second squared. So if we start off by just looking at when it's not moving, we know that the acceleration would be equal to 0, so the net force would be equal to 0, so it would be in equilibrium if it's not moving. And just like before, the tension in B is going to be equal to the weight. We can write the sum of the forces as TB minus the weight. When we set them equal to 0, you see that TB is just equal to the weight. So the tension in B when it's not moving, 29.4 newtons. Similarly, we could determine the tension in A because it's just the sum of the weights. You find the tension in A is 39.2 newtons. So when it's not moving, the forces on each of the blocks are equal to 0. So the tension in each cable is just equal to the weight of the blocks hanging from each cable. However, if in the second part it's accelerating, then we no longer have a situation where it is in equilibrium. And so then the sum of the forces will be equal to the mass times the acceleration. So if it's accelerating downward, to find the tension in cable B, we're just going to set up the sum of the forces is equal to the mass times the acceleration. So again, the forces on B are just the tension minus the weight of B. However, in this case, we can set it equal to the mass of B times its acceleration. Just solving for TB, we know that the force of gravity is equal to the mass times G. If you multiply these and add them up, you find that the tension in B is equal to 24 newtons. So when it's accelerating downward, the tension goes down. To find TA, it's essentially the same thing, except we now have 4 kilograms instead of 3. Here you can factor out the mass of each one, factor out the m on this side of the equation. That leaves you with G plus A. So we can simply multiply and find the tension in A is 32 newtons. So again, when it's accelerating downward, the tension goes down.